Hey guys, this is Mr. Fourth Dimension. Welcome to the Geo project. So today we're going to be working on profiling the side angle side versus the side side side, or timing, or whatever you want to call it. Maybe it's not profiling a big program or something, but we'll definitely be putting these two different ways of computing the area of a triangle to the test by a timer. Now I already started this a little bit once. I started recording and my mic was off, so I've already written a little bit of code. I went and added this loop here. That seems a little big now that I look at it again. We'll see if that's good. And I set up this system to randomize the locations a little bit. Now this is not the best random function, and this function here will even cost us a little bit of time. So we might also try doing it without randomized locations and see what difference that makes. But this is already set up to be what we're going to time, but we still need to set up the timer and stuff. So how we're going to set the timer up is we need to well, first of all, I have defined profiling up here, right? So whenever that's true, all the profiling stuff will get brought in. So now, if profiling, right, then the first thing I'm going to do is I'm going to include Windows header. On other platforms, of course, you can't use that. You'll have to do whatever you do on your platform if you're trying to set up your own timer. So the same basic concepts everywhere, but you will need to Google it and find what you're looking for. I like to just do a timer that just gives me an integer, nothing fancy. Give it some name that makes sense. And I just want it to return like some integer that's been counting up since the program started. So what we need now is we need to look up the Windows way of doing this. Now, I think what I want is query performance counter. That's, if I remember correctly, the microsecond resolution. Yeah. So we're going to use this function right here, and so we need a pointer to a large integer time. There we go. And then it'll return true if it was successful, I'm guessing. So if it succeeds, and we'll set this to -1. So if it's unsuccessful, result will just be -1, and otherwise it'll give us some positive number. And then result equals, and then I don't think you can just do time, because I think large integer is a struct. They don't have a link to it on this page, but I'll just search it. Large integer to union quad part. So they have, like, the union has the D words are the 32-bit low part, high part, and then you can just use quad part for the whole 64 bits. Now it's unsigned, but I don't really care. We'll just cast it. This isn't supposed to be fancy clean code. It's just a quick way to grab a time. Now what we want to do is come down here. By the way, this to do here is what we're working on right now, right? Yeah, so we can take that out. So for profiling, then if profiling, then we need a I64 start time would be system get time, and then later, if we're profiling, again, I don't know that that's the right word for what we're actually doing, but who knows? Doesn't matter too much. Get the time, and then print it. Printf time, and then I went and searched this because it's hard for me to remember sometimes. The way you print a 64-bit assigned integer is LLD, at least on this particular compiler. It seems to be something that's a problem here and there on these printf type functions, which I find interesting. Anyway, that should give us time. Now we're currently timing which one? We're timing side, side, side. So let's see. Okay, it compiles. Let's give it a run. See how much time that takes. 10,011. So that's not bad. The percent error is not too high here, like it's giving me about the same amount of time for each one. Well, that was kind of bad. Like this here, it's almost 14, and this, some of these are almost 10 milliseconds. So how much percent error is that? The point is I want the percent error to be low because I don't want my measurements to sort of be getting affected by you know, random little fluctuations caused by stuff other than the actual efficiency of our code. So 10607, right? And then I gotta, so that's the difference between the highest and lowest thing I can find. So that's like the total range in possible values. It's kind of rough system. And then I'll divide it by about 11,000 because that's about the median, I think. See, that's like a 30% error. Well, 15%, but that's if you only measure from the center to one end. But that's still kind of high. Let's try the other one and see if it's how it compares. We might try a slower test as well, something that decreases the percent error by increasing the number of trials in the loop. But let's see. Whoa, so that's a bit slower, unless it's just the error. But no, it looks like, see, like that again is pretty large error from like there to there. It's at least 30%, or at least that 15%, more like 20% actually. Yeah, that 23 is a huge amount of error. Let's increase it a little bit more. Put those zeros in, so it's a lot slower. And now it takes a while, but it did just about multiply by 100 how long it takes, and you can see that it's not going as nuts. The percent error is a lot lower. Yeah, it's all right around that range. That we're going to say is, what is that, 1.5 seconds. Now let's try the side-side-side formula with this new test. Yeah, that's like, what is that, exactly one, it's about 1 second, yeah. Not exactly, of course, it's got stuff afterwards, but you can see how low the percent error is now. It's like maybe 1 or 2%. That's what I want. I don't need it to be so low that it's like decimals, but I just want to make sure that I'm not getting any crazy effects. And this looks like it's about 500 milliseconds faster at this point, which, if I take a look at this, this is 1 million, so we're actually performing this operation 1 million times. I want to see how fast it is when I don't do the computation at all, and I just do like real 32 area equals 10, right? So I'm not doing anything, everything is exactly the same except I'm not doing any computation. How much time are we spending on the setup for this? That is another question we should ask. Wow, so that's about 600 milliseconds, right? So that means this was taking about roughly 400 milliseconds to do the actual functions 1 million times, and this was taking more like what is that, 900 milliseconds. So that means the side-side-side formula is almost twice as fast, which is a pretty big difference. But I think that answers our question about which one we prefer, and that's that the side-side-side seems to be faster. But that doesn't, I'm going to keep this code for now. I mean, that surprises me, for one thing, because I didn't expect that, and the reason I didn't expect that is that side-side-side involves first finding 3 distances, whereas this only involves finding 2 distances, and then I was figuring even if Even if this distance is faster than this 3-point angle, which I wasn't sure which one would be faster, surely the simplicity of just multiplying things together and taking a sign is better than doing all this addition and multiplication and then more, and like storing a variable and then doing more multiplication and subtractions and then a square roots. Like, it seems like this should be faster, but maybe the 3-point angle is a lot slower than the geodistance. That could be what's going on there. Or maybe it might be that the math sign and the 3-point angle together are pretty slow. Maybe the trig's a lot slower than the square root, which is being done, twice as much. There's 2 extra square roots in this path and 2 extra trigs in this path, so maybe square roots are a lot better than trigs is what's going on here, or maybe there's something else going on. So maybe at some point we want to investigate more, because maybe we can speed this up. Maybe if we speed this up, this becomes the better way. But for now, we have our answer. Currently, we want to use this version, but I'll leave this here so that it can be used in the future. So, we have our answer on that. We can now say that we've got the better of the two for just generic 3-point area is the side-side-side formula right now. And then I'm going to add a to-do here, which is I want to clean up this preprocessor stuff. Right? Well, actually, I have enough time, don't I? Let's do this right now. So what I want to do to clean this up is I want to say I want to make these in the macro. Start timer, right? And it'll just be like that, and then I want to replace this all with end timer. And then what happens is I come up here to where I have this, and we define these as macros. So define start timer as, and then we just do this code. And then define end timer. We'll come down here, and this is 2 lines of code, so we'll actually have to do a multi-line macro, but that's okay, that is fine. There we go. So those are our 2, I'm going to take those out, so it forces me to use semicolons because I prefer that. And then what you do is you say else, so if you're not profiling, then define those macros anyway, but just make them do nothing, so that they're just, in the actual code, they're just nothing, right? And then we can take out these ifs in the main part of our code, and all we have is start timer and an end timer markers, right? And that should still compile, and then we can just, man, I don't know what's taking this thing so long. And then we can just say profiling be gone, and it'll compile. Ooh, what's the matter here? Rand. Is Rand not available from anything I'm including except for Windows? That would be interesting. Well, for now I'll include, what is it, like standard lib? Does that have Rand? I forget. Why is this compiler being so slow? I don't know why, what business it has taking that long. But yeah, so another thing to do is I want to move this rand, well, no, that's just sort of a temporary thing because it's in the main. If we ever do use rand, which I don't know when we would, but maybe we will, we won't actually use the rand directly. We'll probably separate it out into math and do some work to make it better and faster. So that's cool. Looks like we got some good stuff done today. So we'll be starting on something a bit new tomorrow. See you guys next time.